Okay, so number 2 in the homework, it says we have the sine of 2x plus the cosine of 2x squared is equal to 1. So what I'm going to do here is just get rid of that squared right away. Take the square root. Whenever you squared something square, whenever you take the square root of something squared, it turns into absolute value. Absolute value will turn into plus or minus 1. So the way that we solve a problem like this is we say the sine of 2x plus the cosine of 2x could be 1, or sine of 2x plus the cosine of 2x could be negative 1. Let's use our double angle formulas. This would be 2 sine of x cosine of x plus, now we have 3 options we could use for this. One thing I'm just seeing is this 1 over here. If we bring it over and we want to try to make it equal to 0, I want to try to use this formula, 1 minus 2 cosine squared of x, because if you subtract 1 on both sides, it'll equal 0. If you try to use the sine formula was 2, I think it was, what was it? It was, yeah, I'm using the wrong formulas here. What I'm trying to do is get rid of this 1. So what I want to have is I want to have a positive 1 on this side, so that when I subtract them, it would equal 0. So the formula with the positive 1 would be 1 minus 2 sine squared of x. If we tried using any other formula, it would get more complicated. And if we tried using the formula 2 cosine squared of x minus 1 equals 1, if we bring it over, the 1's wouldn't cancel. It just makes our life a little bit easier to be using this formula. Now on the other side, if we want to get the negative 1 to cancel, we could use the opposite idea. So this would be 2 times the sine of x, cosine of x. But if we want to bring this negative 1 over and have it cancel, we should have a negative 1. So if you look at your formula sheet, if we use 2 cosine squared of x minus 1 equals negative 1, when we go to bring these together, it will equal 0. We'll just make our life a little bit easier. I think Mr. Cilio on the other side, I think he actually used a different formula, but you could take a look at the pictures from the answers and decide what you want to do. I want to try to make them equal to 0. So this would be 2 times the sine of x cosine of x minus 2 sine squared of x equals 0. We could factor out a 2 sine. And we get cosine of x minus sine of x is equal to 0. When is 2 times the sine of x equal to 0? When is sine 0? It would be 0 when x is 0 degrees or 180. And when is cosine of x minus the sine of x 0? Or when is cosine of x equal to the sine of x? One thing we could do is we could square both sides. Let's see, one thing that I'm thinking is you don't really want to be dividing by an expression with x in it, because you could lose values. So if I divide by cosine of x, we just get tangent of x equals 0, but we might eliminate some of our values. If I square both sides and then divide by cosine squared, I get, let's see what we get here. We get tangent squared of x is equal to 1. as opposed to if we didn't square both sides, we would just get tangent of x equal to 1 if we just did cosine of x equals sine of x and divided both by cosine of x. So I hope you guys could see that if you just divide by cosine here, you would just get tangent of x is equal to 1. But if you square both sides, then you get tangent of x is equal to positive 1 and tangent of x is equal to negative 1. So you really have to be careful when you're dividing by a trig function with x in it. Well, when is tangent 1 at 45 degrees and at 225 degrees? When is it negative 1? Well, in the quadrants where tangent's negative, that would be 135 and at 315. All right, so I know this problem's kind of long. Let's take a look at the other side. I already explained why I chose to do this, so that when we bring the 1 over, we would get 0. So we would get 2 times the sine of x cosine of x plus 2 cosine squared of x is equal to 0. We could take out a 2 cosine of x, and we're left with sine of x plus cosine of x is equal to 0. So when is 2 cosine of x equal to 0? When is cosine of x 0? Cosine's the x value. It would be 0 at 90 degrees. And at 270. And then when is the sine of x plus cosine of x equal to 0? Or when is sine of x equal to negative cosine of x? Again, I would be really careful about just dividing by a trig function with x in it because you're going to lose some of your answers. If we do square both sides, get sine squared of x is equal to cosine squared of x. And then we bring both on the same side. I know the Pythagorean theorem says sine squared plus cosine squared is 1. Well, that would mean that sine squared would be 1 minus the cosine squared of x. So I get 1 minus 2 cosine squared of x equals 0. Or cosine squared of x is equal to 1/2. Finishing this, if you take the square root of both sides, we get the cosine of x is equal to plus or minus 1 over root 2, which we get from 45 degrees. Cosine would be positive in these quadrants. Cosine would be negative in these quadrants. So we would get as our answer, x would be 45 degrees, 135, which we already have, 225, which we already have on the left, and 315, which we already have. And actually, we already have 45 too. So that just gives us duplicate answers. These would be the 8 answers we should be getting. On the back, so I'd imagine a lot of you probably had trouble with number 3. Let's try to do that one together. So number 3, it says the sine of 4x is equal to negative 2 times the sine of 2x. Now there's a little bit of a trick with this. The sine of 4x is actually the sine of 2x plus 2x. And we could use our double angle formula right here. The reason why I wrote number 3 like this is because if we use our sum and difference formulas, this one's a little bit tricky, but what we could do is we could write this sine of the first, cosine of the second, same sign, and then cosine of the first, sine of the second. And then this would equal negative 4 sine of x cosine of x. There's going to be more problems like this coming up, so just be aware that we could break that up and then use the sum and difference formula to solve it. At this point, I know the sine of, let's see, what do we have here? This is actually the same thing, so we can combine like terms. And I'm going to be using a formula to further simplify this. The sine of 2x was 2 sine x cosine x. And the formula for a cosine of 2x, again, we have a few other formulas we could choose from. But let's see what we could do. Let's see, we could write this cosine of 2x as 1 minus 2 sine squared of x. All right, so what I'm going to do is I'm going to try to clean this up a little bit because there's a lot of similar terms. So this would be 4 sine of x cosine x that we're going to have to multiply by 1 minus 2 sine squared of x. And then I'm going to bring this term on the other side. So this would be 4 sine of x cosine of x minus 8 sine squared of x uh, 8 sine squared of x. Let me see here. That would be minus 8 sine to the third of x cosine of x. And then plus 4 sine of x cosine of x. All right. So now at this point, let's see if we could factor something out of everything. I could definitely take a 4 out of every single term. I could take a sine out of every single term. And I could take a cosine out of every single term. So I would get 1 minus 2 sine squared of x plus 1 is equal to 0. So the question is, when is 4 times the sine of x cosine of x equal to 0? And when is 2 minus 2 sine squared of x equal to 0? If we divide by 4, this is asking us when is sine of x 0? Well, sine of x would be 0 right here. 0 degrees and at 180. When is cosine of x 0? Cosine of x would be 0 right here and right here at 90 degrees and at 270. So now let's try that other piece. If we bring the 2 over and divide by negative 2, sine squared of x is equal to 1. And if we take the square root of both sides, we get sine of x is equal to plus or minus 1. Well, that would happen when is sine positive 1? Right here at 90 degrees. And when is sine negative 1? Right here at 270. We already have those. So these would be the answers that would work. All right. And then the other 2 problems on the homework, I thought those were pretty straightforward. So we'll just stop here. If you have any questions, you can leave them in the comments. Or, of course, you could send me an email. Thank you very much. Have a nice day.